Okay, welcome to a video on 2.7, proving angle pair relationships. Before we do that, let's do a little more algebra. We want to solve for x. X is right here. So what I'll probably do is combine everything on the left side first. 3x plus 33 equals 90. 3x equals 57. Therefore, x equals 19. Interestingly, that's almost the same equation. We have a 180. So 3x plus 33 equals 180. So replace 90 with 180. 3x equals 147. X should equal 49, I believe, if you use a calculator. Then here, x occurs twice. Sorry, 3 times, actually. So I'll combine everything on the left side first. Sorry, right side first. So subtract x. 5 equals 2x minus y. Then add y to both sides. Five plus y equals 2x. And then divide by 2. So is x equal 5 plus y over 2? So now you have x isolated. So we did 3 steps. Actually 4 steps, really. We combine like terms on the right side, then move the 3x from right. Sorry, move the x from left to right is the second step. Add a y from right to left for a third step, and divide both sides by 2. So now a theorem, some more terms. A theorem is a statement that can be proven. Once you've proven a theorem, you can use as a reason for other proofs. So it's like a theory. You have a theory about something, you want to prove it. And all the theorems here have been proven in the past. So congruent supplements. What this means is that if angle 1 and 2 are supplementary, so if 2 angles supplement to the same angle, so 1 plus 2 equals 180, and 2 plus 3 also equals 180, then naturally speaking, these would have to be the same, right? I mean, let's say angle 2 is like 140 degrees. Then angle 1 would have to be 40 degrees, and likewise angle 3. So they have to equal each other. Congruent complements theorem works the same way. If angle 4 plus angle 5 adds up to 90, and if angle 5 plus angle 6 also adds up to 90, then naturally speaking, 4 and 6 must also equal each other. For example, what if angle 5 were like 50 degrees? Then angles 4 and 6 would also have both be 40 degrees. And there you go. So hopefully that seems logical. Linear pair postulate. If you're told that 2 angles form a linear pair, then they're supplementary. Therefore, they have the 180. I think we already know that. So if they form a linear pair, then these two have to have the 180. Right angle congruence. All right angles are the same because they're all 90 degrees. So knowing all that information, let's do a proof. So let's look at 2.7.1. So let's talk it out first, as I mentioned. That's what you want to do. So, well, you have to figure out what you want to prove first. Identify pairs of congruent angles in the figures. Well, yeah, it's kind of a lame question, but I think what you have to be told what you have to prove. I'll always tell you that. Don't worry about it. That's just weird. Angle, you want to prove the angle NSP is congruent to angle QSR. So you want to be able to prove that those are the same. Now let's state what we're given. You're given that angle MSN equals angle PSQ, which of course equals 50 degrees. And also you're told that angle PSR is a right angle, which is abbreviated like that. And that's all given. So you can put all the givens as one step. Well, we definitely know that angle MSN plus angle NSP has to have the angle MSP. That's from the diagram. And likewise, angle PSQ plus angle QSR has to equal angle PSR. And that's angle addition postulate, AAP, angle addition postulate. Also, we know that angle MSP plus angle PSR equals 180. And that's going to be using our linear pair postulate because they do form a linear pair according to the diagram. So we're going to have 180. So you could say linear pair postulate. And then you could substitute. You would replace PSR with 90. And so then angle MSP is 90 degrees. So that's substitution. And also subtraction property of equality. Step 5. Now we know angle MSP is a right angle, and PSR is also a right angle. We could say that angle MSP equals angle PSR. And that's just a right angle congruence theorem, because all right angles are congruent. And if you think about it, we have MSP and PSR right here, and they equal these right here. So we're almost done with the problem. There's 2 more steps. And I definitely didn't leave myself enough room here. So it's a pretty meaty proof. And I'm not going to expect you to do these from scratch right from the beginning. What I'll most likely do on our test, actually what I will do on our test, is I'll have this partially filled out and you have to kind of fill in the blanks. And I'll show you some examples later in class. But yeah, so here we got step 6, I'll do over here. So now you can say angle MSN plus angle NSP equals angle PSQ plus angle QSR. And that's due to substitution, because I replaced MSP and PSR with those expressions. And then we could actually drop off the MSNs and PSQs and just say what we want to prove, that angle NSP equals angle QSR. And that's the subtraction property of equality. So subtracted the same thing from both sides because they do equal the same thing as we saw in step 1. So that is a 2-column proof. Again, it might seem pretty daunting, but don't worry, I'm not going to expect you to do one from scratch on the test tomorrow because you guys are still seeing this stuff for the first time. But what I'll most likely do, again, no, sorry, what I will do, I know I say most likely just as part of my vernacular, is give you one that's mostly filled out, but you have to kind of figure out what the statements could be or the reasons could be. So what I'll do is I'll partially fill out this one, and then you kind of fill out the rest. So you talk it out, obviously. So we want to prove I don't know what they want us to prove here. Let me find this out. 90, 89. This one seems kind of weird to me. I don't know what is happening with this one. I'm not exactly sure what we have. I guess you'd have to prove that angle FGH equals angle WXE. That one's a little strange to me. Let's go and cross that one off. Don't worry about it. That was not a very well-designed question. Let's move on to vertical incongruence theorem. This is a pretty easy one. Bottom line is that if you have two angles that are opposite of each other, they equal each other. That's all. So 1 equals 3, 2 equals 4. So in this case, angle 1 is 112, then angle 3 is also 112. And also, because 1 and 2 form a linear pair, that's going to be 68 degrees, because these have to add up to 180, because they form a line. Therefore, angle 4 is also 68 degrees. So you'll do these on your own using information I just shared with you. So like you put 67 here, fill out the rest. Or for the third question, you're going to put 71 degrees right here and work out the rest. And then these involves a little algebra. These are going to be equal to each other. So you set them equal to each other because they're vertical angles. So I'll let you work that out. And here, because these form a line, it's a linear pair, you're not going to set these equal to each other. Instead, you're going to add them up and set equal to 180. You work that out. So that will conclude the video for 2.7.